Good afternoon. Today we will discuss the unit second. In this unit second, the chapter second, rotational motion. In this chapter, first we see the angular velocity. Angular velocity is denoted by omega and defined as the rate of change of angular displacement. Let theta be the angular displacement. Then angular velocity it is denoted by omega, and omega equal to the rate of change of angular displacement, that is the d theta by d with respect to time is called angular velocity. And angular velocity is measured in the unit radian per second. Then now we will discuss the second point, the angular momentum. Angular momentum it is denoted by capital L. Angular momentum it is denoted by capital L and defined as the product of momentum inertia of the body. And its angular velocity. That is, angular momentum is denoted by the capital L, and capital L equal to product of momentum inertia, that is the mi, into angular velocity, which is equal to capital R into omega. That is the angular momentum is equal to product of momentum inertia and its angular velocity of body. Or it is also defined as the moment of linear momentum, that is capital L equal to moment of linear momentum, that is, or which is equal to capital L equal to R bar cross P bar, or it is also that is R bar dot P bar, R bar into P bar, not dot, into P bar. That is the momentum, linear momentum is called angular momentum. Now imagine that the rigid body. Consider this is the rigid body. This rigid body rotating about an axis passing through its center O, and rotating passing through its center O and rotating about an axis passing through its center O with constant angular velocity omega. Now imagine that this rigid body is divided into the number of particles. That is the first particle, second particle, third particle, fourth particle, nth particle, that is n particles of masses. First particle having the mass is the m1, m2, second particle m3, third particle m4, fourth particle, last that is the nth particle having the mass is the mn. And at a distances from the center O, this is the first particle having mass is m1 and at a distance is r1. Second particle having the mass is the m2 at a distance, that is the r2. Like as the third particle at a mass is the m3 at a distance, that is the r3, and so on. That is the last nth particle having the mass is the mm and at a distance, that is the area. body is rotated with constant angular velocity omega about an axis passing through its center O, then every particle is also rotates with constant linear velocity. That is the first particle having the constant linear velocity, that is the v1. Second particle having the constant linear velocity v2. Third particle having the velocity is v3. Last, that is the nth particle having the velocity is linear velocity is v1. Linear velocity is v1 as shown in figure. Then the total angular momentum of a rigid body, total angular momentum of a rigid body, capital L equal to, that is the summation of, that is, or the angular momentum of first particle L1 plus angular momentum of second particle plus angular momentum of third particle L3 plus dash and so on, last L, which is equal to summation of Li. Summation of Li. This is the angular momentum of all particles. That is the summation of angular momentum of all particles. That is the Li. But we know that the angular momentum, that is the capital L equal to summation of angular momentum is nothing but the moment of linear momentum, that is the capital L equal to, which is equal to R cross P, which is equal to, that is the Ri cross Pi. That is the summation of Li equal to momentum of the linear momentum Ri cross Pi. But put Pi equal to product of mass of ith particle into its velocity, linear velocity mi into Pi, which is equal to summation Ri cross or into m1 into Pi, which is equal to summation m1 into R into phi, put phi equal to Ri into omega I. That is the, or R cross omega. That is the relation between linear velocity and angular velocity, P equal to R omega, which is equal to